Yes, today I was able to show you many different theories about how can we forecast foreign exchange rates. So now it's time to see that how can we do this in practice. So it will be nice to have a speed run during the next 1.5 hours to check all these things, but hopefully we can do this. So the easiest way in Excel is just download the time series. So I uploaded this file called Euro-US-Dollar IFM, not IMF, IFM, Cash and Financial Management, here in the seminar. And practically we have several sheets here. So first is weekly data. This is for the simulation. And the second is quarterly data, which contains many different variables. And this will be used for the vector autoregressions. And yeah, so that's all what I prepared, and we will see. Okay, so first of all, if you would like to choose the easy way, then practically we just have to download this thing. Then we have to select in the Excel the data, then forecast, forecast sheet here, and after that we can see that, oh, there is nice forecast. Today is 2023, so 5 years ahead. Well, let's say that 9. Great. Got it. And that's all. So if you would like to have the laziest way available to do forecast, then Excel has its own application for this thing. So practically, again, you just have to select data, forecast sheet, and that's all. We just have to highlight the date and the currency, so not just the currency, but all them together. You can ask the question, how reliable is this thing? Is absolutely no idea. I mean, there is a confidence interval here, there is a confidence interval there. It's in between them. It's obviously above 0 because we are talking about currencies. So if a currency reaches 0, I don't know what would happen. So it's quite impossible. And so yes, this is a close enough solution, but okay. So if your boss in the future requests something like this, then yeah, this is the half-minute approach. Then let's see something more fancier. So this is why we have Matlab, because Matlab is free for us with campus license. Just nowadays the license is not working for some of the students. I mean, some of them, so 80% of them are not able to use this. I don't know why, but not even PhD or some of the PhD students. So at least I can show it to you, how can we work with this one. So Matlab has a really simple interface. So there is the home menu. Here, if we are hitting new script, then the editor will come up eventually, and we should write the code here. Also, if we are not satisfied with the font size, I'm increasing it to 22 because at least it will be visible. There in the preferences we can change this. In the current folder we have all the files in the current folder, which is located here, and the workspace will contain all the data which was loaded in. And in the command window, if something is red, then it means that we have an error message. If it's not red, then it means that the script was running or it has some results. So that's all about Matlab. What I would like to show you today is forecast with GARCH model. Let's say FX. Forecast with GARCH models. as you can see that if I'm using percentage marks, so percentage mark can be made as with shift +5. Just if someone needs the combinations, I'm always writing them up. Okay, and then, so in this case, this is just a comment. So if something is green, then it's not part of the script. Just this is for documentation to show what is happening here. So 0 step is always loading the data. Before doing anything, clear must be done. So in this case, clearing the workspace. Because if you are overwriting things which are already defined, like matrices, vectors in the workspace, then we can have really funny results, which are not that funny if we are realizing that all of our results are biased somehow. So clear is our best friend. Next thing, data equals xls read, bracket opens, upper comma, and the file name here. Upper comma, and what is the name of the sheet? Input weekly. So in the case of Matlab, the functions are always behaving in the same way. So there is always the output of the function on the left side of the equation mark, and there is the function name, and after that there are the inputs inside the brackets. So, and this is quite the same in R, which is the free. I cannot say free version of Matlab because it's a parallel development project, just they are using for the same purposes. So yeah, and also brackets. Save, and upper comma is shift +1. Okay, what do we need here? Okay, nothing more. So if you are running this, then F9 must be used, or also if you are right-clicking and then evaluate session, then for selection is chosen, then practically we are doing the same thing. I'm always using my mouse because in this case you can see that I'm running something, and also in the past F10 was stopping the video recording, and I killed some of the video recordings in the past at seminars because I hit F10, so yeah, it's forbidden for me. Okay, so if we did this, then you can see that the XLS sheet function targets the Excel file. So first of all, if you want to do any of this, then you have to download it into the Documents Matlab folder. And the next thing, that you have to select the sheet of the data. Usually it selects the left one, but it's already has a typo. And we need this one, so that's why we can target this. And then we are the happy owners of the data here. You can see it removed all the dates, all the headers, so now we have just the raw data because this is an industrial software, so we don't need other things here. And last thing, that we need the differential of this. Week-to-week difference of the data, because we need zero mean data. So yeah, what is this? Practically the zero mean data can be used for practically all regressions or other econometric models, because in this case the expected value is not changing in time, so it remains the same. So we cannot run any regression or any other models if it's not ordered like this, because regressions will run, just all the results will be completely biased by unit root issues. So differential is the best friend when we have to work with any macro financial data or capital market data. And we can see the following things here. So okay, it's fluctuating around 0, but also at the same time we can see that there are periods when it's fluctuating more. So obviously these are the crisis periods. So the whole thing starts in 2006, and somewhere here there's supposed to be the 2008, 7-8 crisis, and then there is the calm period of the second half of the 2010s. Maybe there is, I don't know what is happening here, but something happened, so some shock happened in the data. The data source is the Thomson Reuters or Refinitiv Econ database, so it should not be an outlier because of the error in the database. But we can see that now it's calming down, and then COVID or something else happens, so volatility increases again. So we can see here the time variant nature of volatility, so as it changes back and forth. Or when people are saying that, oh, but it should follow a normal distribution, so we can see that it's not. That's why we have also these applications in Matlab. Most of them are absolutely, I cannot say useless, just I'm not using them, but here is this distribution distribution fitter, and it can be useful because we can just select the data, create data sets. So I would like to show you this thing because yesterday I was talking about lack of normal distribution, but let's see it. Okay, apply close, and let's also put a nice stable. So this is where we can see all the problems. So this is the normal distribution, the red line, and the problem is that this one is ending here. So it says that after this level, so after the changes of 5 euro cents, absolutely in a plus-minus direction, that is impossible to have bigger changes in the exchange rate of the euro US dollars, while at the same time in real life we can see that, oh, there is a data here, there is a data there, there is also some appearance of changes here and there. So practically the market generates much more erratic changes than it should be accepted by normal distribution. So this is the key problem here, and that's why fat tail distribution can be much better. Just the problem is that the mathematics of fat tail distributions are way more terrible. So that's why everything was calibrated to follow normal distribution in theory, because you can build up models way easier with this. So how can we solve this issue, or how it affects us? Practically it's not a great problem, because now we are living in 2023, so most of the models are prepared for that one. And this is when we start to check the beauty of GARCH models. Okay, so there is a really nice professor at Oxford University called Kevin Shepherd. And since we are using his work here today, then it's necessary to show his website and say that thank you very much, Mr. Shepherd, because he developed the MFA toolbox, which is practically a folder with functions, and it's way better than the official Matlab folder, and it's free and it's better, so we like this. And also I uploaded it here smfa toolbox.zip on CoSpace. But if you are extracting it to the documents Matlab folder, then inside the MFA toolbox, which I can refer here, we can find many things, but what is required by us is the touch function. Okay, we don't need a function here, we don't need these things here. This one neither. So the documentation of these functions are really good because practically it describes at the beginning that what is this, how can we set up the model, also what are the inputs. So the epsilon is the zero mean data, so that's why also differentiation was necessary, because it says so. There are the different parameters. There is the error type, so that's why it's also necessary, because we can set up a normal distributed, but we know it's not a normal distributed, so we can check a skew-t distribution here. Let's save it. And after that there can be other optional setups, but we don't need to define this one. Also in the case of the outputs, there will be the parameters. Okay, I will show it to you. Log likelihood, so we can define the fitness of the model. This is what we are looking for, because these are the conditional variances, and the rest is absolutely useless for us. So yeah, so practically we are here for this function here, and then we have to define that, okay, epsilon is not epsilon anymore, it's ret. These are the returns. So the logarithmic, sorry, just the changes. We are not using logarithm today. Luckily, because the data sets are really small, so we don't have to smooth them out by using a logarithm. Then there is this POQ parameters. And the error type. So, what are these parameters? If we are going back to GARCH model Wikipedia, we can find, the equation here. So practically it says that today's volatility depends on yesterday's volatility and also I days or weeks before. So this parameter, which is defined by the P, and there is the Q parameter, which defines that how much shocks or innovations are generated by this skew-t distribution. It could be normal distribution, just we know that it's not normal, so let's create something crazy. And also Q days backwards, what we can use here. The question is that, is this coherent with this one? So P positive scalar integral representing the number of systemic innovations. No, they are using backwards. Cool. So because here the P is the shock from the volatility, so that's why documentation sometimes it can be necessary. So number of past shocks it's absolutely simple, because usually models completely working well if we are just using the last week's data. So practically in performance, in fitness, it doesn't matter so much if we are just increasing it to 2. So I don't want to start to build up different setups and to compare them, because it will just take time. In this case, we just see that, okay, 1-1 model is perfectly enough. Then also there is this O variable, which is right now it's missing from here because simple GARCH model was not able to deal with this one. But it can be really important that sometimes prices can react different ways if the volatility of the asset can be react differently if the price of the asset increases or decreases. So, for example, if share prices are falling, then volatility increases much more because, oh my god, there is a crisis on the market. But if they are just gradually increasing, then the volatility is not reacting at all or not so much. So that's why the direction matters, and that's why it's much better to recognize this one. And suddenly, if we are recognizing that it's asymmetric, then we have the GJR-GARCH model. So, as you can see, there are many multiple GARCH models here and there. Practically, this is the one which survived until today, because the rest is not widely used or not used at all. So these people developed it in the early 90s, and this is how it looks like. So, or at least one representation how it looks like. And what we can see here that, okay, the equation is fancy, but at the end of the day we just have to set O equal to 1, and after that we're happy with that. So we don't need any further actions. Settings. So now we can be the happy owner of the GARCH model, and this is what we can't see because it's too small for you. So we have to create a bar graph. So these are the function coefficients or model parameters. There is this one. The first one is a constant. It's absolutely 0, so who cares? The second is the importance of the shocks. Yesterday I mentioned that it's around 10%, and we can see that it's actually 9% right now, because some of these shocks are at least 2% of the data changes is happening because of asymmetry. This is really smooth right now because we know that the euro-US dollar is following this sinus behavior, so there is no clear depreciation or appreciation, like in the case of Swiss franc or in the case of Hungarian forint. So this is really smooth here, but at least it's recognized. And also we can see that 87% of the volatility is coming from last week's volatility. So it remembers. If it was not able to read or price in the asset well, then it's not able to price in the asset today as well. So so the market remains crazy, or if it was calm, then it remains calm as well. So this is the key features, because these are just the parameters of the QT distribution. Nobody cares about them, so these are the fancy ones. Yeah. Okay, so now we have the model. I would like to show you also that what we have calculated. So this is the HT. If you find HT somewhere in the textbook, then it means that this is variance in time. So the T is the time, the H is the standard deviation just on squared, because obviously we don't have Greek letters in Matlab. So, and you can see that this is the week-to-week change in the volatility, or in the variance of the exchange rate. So we can see that some time periods the volatility is really low. Sometimes it's increasing into the skies, then it's falling down. Then there is this outlier thing, and otherwise it's quite calm. I don't know what kind of data artifact is this, but okay. The same thing what we were able to see in the case of returns and also in the distribution. Okay, so we can see that, yeah, this thing is changing in time. So this is not just one standard deviation. If we would calculate the mean of this data, then it would be really close to the standard deviation. So obviously they have to be related to each other. But right now, our purpose is to use this model for simulation. So we fitted the model, then 1.A and this is why we have start simulate. In this case we don't need so many things here because there is the length of the simulated data, so we need 5 years ahead. This is weekly data, so 20 or 52 weeks can be used. Parameters are coming from the old data. P, O, Q, we defined it already. Error type, it's error type. We don't have to define touch type because it's 2 by default. So we can do this way. Just the problem is that yes, this is just one simulation, so who cares about this? So let's have for j equals 1 to 100. 100 simulation is quite robust. So we can say that I don't care about this one anymore because we need the simulate data, not the simulated volatility. Right now, if it would be for option pricing or something else, it would be significant for us, but right now it's the simulation, so the simulated returns changes are relevant for us. So let's run this, and if we are doing it efficiently, then we can see that something like this is generated. So we have 100 simulations, and it will change from time to time. So we have to connect this to the present, which means that this 100 input data should be added to the last known data. So for j equals 1 to from this number, and I'm always using j for the columns, I for the rows, and in this case I can see which one is what. And or let's have this variable name, and let's start this simulated data with j, because this is just one simulation, the first point, and we have to take the last known data, so data, and so last row, it has only one column, so it's quite obvious that we have to do this way, and plus the first simulated data, so this is, one. So the first simulated data in the j column, so we can see that these are the columns, these are the rows, and after that we can remove this because it's not part of the cycle anymore, because this is just happening on the first day. We can see that there were no referring back to the I, and oops. Yeah, we can use Ctrl-Z, Ctrl-C, and Ctrl-V also like in Word. But now, after the second day, we can say that, oh, now we can use I. But here, instead of using the data, because we are running out of the data completely, so now we're just building it upwards. And then we can have something like this. So now we can see that all the simulated returns, which are quite crazy because it's based on these strange distributions which are asymmetric, so practically it can have an appreciating or depreciating trend, and deals with this volatility thing, is we can see that this is just one possible simulations, but we can see here 100 possible results. So if we are just rolling forward, and let's just check that, okay, but what happens if we are just picking the exchange rate at the end of each years? So for I equal, we need 5 years, so we need 5i. Let's call it year. And the same thing here, just in this case, obviously we have to multiply it by 52 to get the why it's 5? Sorry. All. So this means all. So all the columns I would like to capture, just the specific rows must be collected. And now we have, yes?
We can only do this if we know that the first data is from the first week.
Yes. Yes. It would be nice. Right now the data set ends in September, so yeah, but this is for educational purpose, okay. So we can say that. Yeah. So these are the possible outcomes. So this is the 100 simulation for the first year, 100 simulation for the second year, 100 simulation for the third year, and so on. And now we just have to see that, okay, but what are the optimistic, pessimistic, and middle scenarios? So optimistic scenario, middle, pessimistic scenario, and should we do this way, or can I do it faster? Maybe it was not so necessary to define it as, so we can put it inside the for cycle and just grab everyone, because practically what we need here is the quantile of this specific data set, just to say that, okay, I need the 0.05. Then we will see that this is this the optimistic or the pessimistic scenario, because I'm always confusing them. But this is the middle, this is the higher one, and hopefully if we are checking the bar diagram of the optimistic one, oh, if I'm putting it into the for cycle, even it can have results for each year. So that was a coding error. So we can see that this is the optimistic scenario, maybe let's call everybody in a different way. So scenario 1, scenario 2, because in this case we just have to check the same variable instead of just copying and pasting 3 variable names, and at least we can see that what happens. So this is what we worked on. So there are many different ways how we can simulate data. The end results are always similar, because here we can see that, yeah, this is what happens if one of the currencies depreciating a lot. What is the denomination here? I mean, which one is on top? Euro, US dollar. So right now, yeah, if it's going downwards, then it means that there is depreciation inside the euro. So this is definitely a problem for us if we have to import components from the US, or at least we have to pay in US dollars. This is the optimistic scenario, so when the euro appreciates excessively, and we can say that, so we can find examples from the history on such exchange rates, so it's not impossible. We can say that, well, somewhere here peaked the euro in the past as well, so okay. And the middle scenario is that nothing happens, so it remains here. This is the expected euro exchange rate scenario. So after this, we can use this for modeling and evaluating the different. So our business plan, we can use this for evaluation, and also we can check that how the different hedging strategies will operate or perform when we will define them as well. So, because maybe for us it will be absolutely not relevant to deal with such a risk. First of all, I have to come up with some kind of expenditures, because right now I'm using complete the euro only, so maybe I have to import, not the engines because they are definitely made in Europe, so I have to import the solid rocket boosters or something, some relevant component from the US dollar to show you that how this thing can mess more profitability up. But right now we can be the happy owner of such variable, so I have to save it for the future. Okay, so obviously if you are running this again and again, the results can be a bit different. So just for fun, let's redo the simulating part. But we can see that they are quite robust. So maybe they are going up or down, but practically the scale of between somewhere in 0.5 and 1.5 will be similar. So yes.
Excuse me, how did we decide the conditions for the pessimistic and optimistic scenario? Like the 0.35, 0.95?
Yeah. So in this case, practically this is these are the two extreme outcomes. So 5% probability on one direction and 5% probability on the other direction. So we are at the tails of the probability distribution. So, but still, we can have a lot of data because if you are going just to 1%, then it would be so infested by extremities that this 5 is much more reliable, and we can see also that it's quite robust here. So let's keep this thing, and let's also save some comments, because it's always good to have some nice things in the documentation. So okay, let's zoom in because you have to see it. No, GJR. One. So QT distribution, if you would like to imagine one, yeah. So this is the function. What a beauty. And do we have any picture of this? Usually there are some illustrations, but right now Wikipedia is saying no. Then at least let's go back to not to skewed but t-distribution. So in the case of t-distribution there was, yeah. So it's something like this. So it's going up, it's allowing a lot of extreme values. It's not symmetric, so it's the one direction can be more. So it can allow depreciations more, or it can allow appreciations more. So this is much more realistic. But at the end of the day, let's define that these are numbers with 2 digits. So this is the constant, which is cool. These are the alpha. These are the shock parameters. This is the gamma. Relativity, asymmetry parameter. And this is what we can see, that this is the beta, the weight of past variance, and these are just the skew t distribution parameters. This one is maybe the skewness, so if it's negative, then it means that it allows more depreciation for the euro than appreciation, but it's slightly really close to 0, so it's quite good. And this is the fat tailness, so how much extreme values are allowed in the process. Okay, so this is the analytical part. Then let's grab also some fancy HT, because later on when we are working with options we need this data anyway. So input weekly. No, sorry. Yep. So now we have variance for each time periods, which is nice. And I think that that's all the practical applications, because at the end of the day we just need the scenarios. So here, okay, this is the pessimistic. These are the middle, and these are the optimistic scenarios. Yeah, so this is what we use. Okay, still they are numbers, so we can use these things in the reports. Okay, and also let's save the Matlab script if anyone needs this in the future, because it's so beautiful and I was able to do this without so much failures. Okay, I was able to do this last year as well, but If someone is interested in much more details, then next semester you can apply on risk management in finance, where we can process all this rabbit hole, but right now we can say that we can do this way, and at the end of the day, what is relevant from financial management point of view, that we have this data. So, and if you're interested in the details, you can check in the chapter 1 and section something what I mentioned yesterday in the lecture notes. Yeah. So, next thing, supposed to be the model VAR. So if we are going back to the lecture notes, lecture material, section 5, why did I added contents table? Yeah, this is what we did today. Oh, there is even best fitting selection, but yeah, skip this part. It was already best. So now VAR forecasting. Practically, our job today is to do something like this. So, okay, this is French government bond, but I prepared with German or Eurozone data. Ah, it's Eurozone. It's even better. So it's not just for one country, but for a whole Eurozone. So practically this is just the international Fisher rule, and we just have to build this up in a model. So you can see that what do we need here? We need the CPI. These are quarterly data, so this is why this can be smaller. We have the exchange rate here. Oh, let's give a different color. So this one. We don't need output gaps here because this is not part of the international Fisher rule. If you would calculate Taylor rules or would move into much more sophisticated models, then we can choose between GDP, industrial growth, greenhouse gases, and so on. But right now, this is not our topic. These are the interest rates, government bond yields, long-term government bond yields for 10 years. This is also an average for the Eurozone, this is for the US. So practically we have everything here for a nice start. And also we have some dummy variables to represent recession in the Eurozone, in the US. This is coming from the European Commission. This is coming from the National Bureau of Economic Research in the US. Dummy ASM, so if any member state got funding from the European Stability Mechanism, then I also collected all the quarter of years because it was nice. And also, what we should not forget, that if we are running any kind of forecasting. Okay, so right now the data set ends here in last week of September. Well, we are 1 year later, but okay, I did not update this part. Sure. So we have to define the data set that this will be the end. And in this case, everybody must be ended here because otherwise Eviews will be unhappy, and we don't want an unhappy Eviews. So I should delete here and there everything. And I'm always pessimistic about forecasting with VAR models, so I'm really happy if we can achieve significant results for the next 5 quarter of years. So let's say that we are just saying that, can we have a forecast for today, because practically this end of September was a week ago, so we can check that, okay, if we are running the model, maybe statistically good, but does it have any meaning for today? Because now we can validate that this thing happened or not, what is forecasted. So, what is also relevant for us that for the forecasting time period, we have to define the dummy variable still. So it cannot be empty, because if you just say that, oh, I'm not able to run, but it doesn't tell us why, so we can mess up several hours until we realize that, okay, this was missing. So we need the date, we need the dummies, and after that, at the end of the day, everything can be perfect. We could use Gretl, which is cheap and which can solve the problem, but I would like to show you more fancier stuff. So that's why we will use Eviews. So if we are loading in the data, not you, no, because I made changes. So file, import from file, and Matlab, and EURUSD $IFM input row. Next. Oh, thank you. So usually it's able to realize what is a date. Sometimes it's not, but still we can, in this case, set up the frequency, but right now it's good. So finish. No, we don't want to link this. Existing data. I don't know how, but this window was moved around. So let's keep it there. Okay, so next thing. I mentioned already. Oh, this is from the past, but it can be useful, so I don't want to delete it right now. So I mentioned that so there are, in the case of sampling, we need 2 time periods. So we need a training sample where 90% of the data is collected. In the past it was smaller, just now everything is so hectic in the economy that we cannot give it or check it lower. And also we need training and a test sample. So this is the remaining 10%, because this is how we can check that what is happening with the fitted data and the real data. So yeah. So with the time frame, so for sample, (2006), first quarter of years. So this is quarterly data, as I hopefully mentioned. What do we have here? It will end in the third quarter of 2022. Let's go back here. So the observation number is absolutely not 71, because this is for the whole thing. So 71 minus 4, 67. Okay, so now we have to grab this number multiplied by 0.9, so we need just 60, and the remaining 7 will be used as a test sample. So we just have to truncated the data set to something else. Okay, so it's 21. Not good. 20. This is when the problem starts, because you can see that most of the high inflation periods are out of the sample. So this is when we are calibrating everything, and yeah. So this is a completely different world economy than what we can see right now, but okay. And then the last test sample will be containing everything. It was third quarter. If we are checking this here, then yeah, this is the third quarter. So yeah, because in the case of the test sample, we need doing so when we will define it, then Eviews will require the whole stuff to forecast. Maybe let's say that. Yeah. Okay, so now we need our friendly econometric model. So the main issue is that we always need a hierarchical order between the variables. So where the shocks are coming from and where they are going. Obviously, at the end of the day, all the shocks will land on the head of the exchange rate. And before of that, we can decide. And obviously, if HCPI, so Harmonized Consumer Price Index, is representing the whole balance between aggregated supply and demand, so this should be the first one, because interest rates will react on monetary policy, which reacts on CPI, because this is their targeted macro variable. So at the end of the day, then the euro will react on this. So this is the direction of shocks. Practically, if you are creating any model, always this ordering will be the most significant thing, because reviewers will ask for it. So you have to defend it. And also sometimes we are just mixing it up to see how robust the model is, but so variables, then we need leg number. It's always through 1 to 4 quarter of years, and we need the exogenous shocks. Which are coming from the outside, and these are represented by the dummies. Dummy. I don't want to add the COVID, because COVID is already represented inside the recessions. So it was a great idea to include, just it was not working. So let's exclude them. For them, the ordering doesn't matter, so we just copy it in the software, and we don't have to. You can see here that differentiation is necessary for any regressions, so that's why the D's are here, because otherwise it's not zero centered and it will fail. But now we can. How can I zoom in? Eviews. Control ++, nope. View. Nope. Options. General options. Fonts. It would be nice to have bigger fonts. Okay, graphical defaults. No, these are absolutely not. So let's go back to general options. Okay, I cannot see any zoom. So yeah. Okay, so in the case of VAR model, we just have to quick estimate. No, this one. Estimate VAR. Endogenous variables. We can just add the model variables here on the top. Then we just have to say that okay, we need these legs. So past. We are using all the past data from the last 4 quarter of years, so that's why it's 1 to 4. Exogenous shocks are coming here. And also estimation sample, we should not forget that we had to set it this one, but since we defined it here, then it will be also defined here, so we don't have to care about this one. and hit OK, and hopefully it's not failing. Good, it's not failing. Let's remove the command window because now is this command is disturbing me. First of all, we need the diagnostics. So residuals, not autocorrelated, and it should be normal distributed. Yeah. Okay, how can we do this? In view menu, we can see residual tests and autocorrelation LM test. It's so cute that 11 has always this bug. But so if you are reducing it to 5, it's always used 1 plus the actual lag number because of reasons. So we can see that here this thing should be bigger than 0.05. So at autocorrelated, if this test, come on, it doesn't matter so much if 1 or 2 cases are bigger, but we can see that right now everybody is happy, so we can say that, yeah, this one is green. Then let's see normal distribution. So now we can use it for past analysis, but let's see that can we use this for forecasting? We can! Okay. Okay, maybe we should copy the whole thing. I don't want to copy everything because it would require a lot of space, but this is what we are looking for. Maybe let's copy the header and if on the residual normality test, P is bigger than 0.05. This is why we are working with low frequency data like quarterly or annual data, because at higher frequencies like weekly or daily data sets, it would never reach above 0.05. So they are so crazy, but at lower frequencies we can get this. And this is why we have to use also the dummy variables, because this can help. These are helping a lot to achieve this. So they are eliminating all the crisis jumps and other problems. So now we can see that we can use it happily. Also, if it would be a panel data, then we should use the AR root graph. We should not use it right now because this one is ugly. Someone has some kind of co-integration. So two variables have a long-term common trend, but right now let's ignore this one. So let's imagine that it never happened. Okay, but let's see that does it have any kind of meaning. So if we are checking just the shocks, 11, Eviews 11 is a bit underdeveloped compared to the 13. So now we have so many different fancy standard errors, and also we can define the size of the whole confidence interval system, but none of them significant. This one is nearly significant, but no, it's not. So we created a model which is completely perfect from diagnostical point of view, and it's utterly useless from econometrics point of view, because not even the purchasing power parity is working, because the line here is around 0. The confidence interval in negative is negative, this one is positive, and all of them should be the same, or positive or negative, but all of them should have the same value. And This is utterly useless, but this is just for short-term reactions. So let's see if we are running a structural VAR model which focuses on the long-run relationships, because it's a Blanchard-Coua approach. Accumulated responses can be used. Impulse response should be defined by structural decomposition. And now let's use Monte Carlo because it's nicer, and finally we can see something. So this one is the sovereign spread. It's significant, so we can see that if we are giving higher premiums in one country, in the Eurozone, then the currency will, so this is the depreciating, so the currency will appreciate, the euro will appreciate, which is nice. This is economy 101. This is the shock one, is the inflation difference. And as you can see, since the data ends before 2021, inflation has absolutely no influence. So this is what I mentioned, that the data set completely biases everything, because here you have absolutely no idea about the inflation will be run away within the next quarter of years, because we are locked in the past data set. So shock 3 is just the US dollar euro exchange rate itself, so it's always a feedback from itself, so it's no big deal. So now let's copy all this thing to the clipboard. And we are the owner, not you. And we are having this. Significant if L and epsilon is bigger than USD, then epsilon, then euro appreciates. Yeah, economics works. Economics works. At least. Inflation is, useless. Okay, but let's see the significance or relative significance of this thing. So this is defined by the variance decomposition, and this just, we need just the table. Yeah. Because I can prepare a much nicer output from this one. So this is the sovereign premium. No, this is not the sovereign premium, this is the inflation. Sovereign premium and the fixed rate, and there is also some standard error, but nobody cares about this one. What is relevant for us, that this is a number with two digits, just we have to compare or convert the decimal commas, and we can see, so inflation has only 4%, 5% of importance in the model. This is utterly useless. Sovereign spread at least has something between 14% to 22% relevance, but we can see that it has only a significant influence in the first 3 quarters of years. So it has also short-term influence. So after its influence dies out. It's still nice, just obviously it's the currency market is way more dynamic than just to identify, oh come on, any long-term effect. So we can say that, yeah, cool, okay. At least what we were able to find is relevant. Then, Finally! Now we were able to say that we were able to find something which has a relevance, so now we can do the forecasting. SOF with the standard error. It's always the wrong one. I don't know why, but even the newest version of Eviews has the wrong time frame here, which is bad because the upgrade costed me 130,000 Hungarian forints this summer, so, and still there is an unable to compute missing data. What? What is your problem, my dear? Third quarter, yeah. Okay, let's check it until it's available. Forecast sample. Why? But there is all the data available here in the whole sample. 2022 third quarter. This is the third quarter. If we are checking, then this data is here, this data is here, this data is also here. They are here. They are also here. And this one? Okay, first of all, can you run at least on itself? Nothing. Oh. Static forecast, something. Was there any kind of missing data in the dataset? Now let's check it because... here! And this is messing because it should be, so until in the sample data there is something missing, then it should be no problem. But okay, let's eliminate the first quarter of years. So there is an expected maximization method built in. No, please don't do this to me. I still have 11 minutes for debugging. Let's do the same thing in Gretl, because why not? If we have the same problem, then it's a database issue. If we have different problem, then it's a software related issue. So speedrun in Gretl. Okay, open, then input row. Yep. Oh my god. Okay, we need the differential of this thing, this one and that one. Add differences. I mean... define new variable. Inflation equals what was the name of these things? CPI. SVB minus CPI. That. Okay, now we have this. And also the second thing will be add, define new variable, sovereign spread equals Western epsilon. Cool. Now I have to calculate these differences. Nice. Then we have to set the sample, setting range 1 to 60, and also let's increase it to 1, because we know that there was a missing data. And then we have to model multiple time series vector regression. This is on the top, this is under, and this is here. And also we have to add the recession dummies here, and then go ahead. Yeah, we already tested it, so it works. So now we just should have analysis forecast 0 US dollar. Then it starts here. You can see that this is a free thing, and it already realized that what is the range. So, okay, automatic forecast dynamic auto sample, show fitted value for pre-forecast range, error bars. Let's turn it down to just one standard error, and then hopefully we have yeah, something which is at least working. So this is an Eviews error maybe. At home I will check on my own Eviews, because I had to buy my own thanks to the fast response of the university. And as you can see, so right now this the differentials are not significant at all. So these are the error bars. This is positive, this is negative, this is the middle thing. And also if we are checking, can I copy it to the clipboard? And in this case we can zoom in. This is a problematic issue, because Eviews can forecast not the differential but the actual exchange rate. So it realizes that it should eliminate it, but Gretl is not so wise. So this is the forecasted value. This is the actual value. So it still says that it should be depreciating. Just the context is also problematic here, because it should say that, okay, depreciation will happen while depreciated. Here, in this quarter of years, it's good. Here it's also accurate. Just we can see that due to error bars, it's absolutely not significant. Here there is depreciation in the real life. The model says that it should appreciate. There is also depreciation in real life. It said it should appreciate. There is a depreciation, and in the case of the forecast, it says that it will appreciate. So practically the simulation says that, or not simulation, sorry, forecast says that from now on it will go up, a bit down, but then up. But what we can see here in real life, that it's going down. So this is the beauty of forecasting with macro models, because even if the diagnostics are nice, even if the results on the historical data are also nice, still the forecast can be completely crazy or inaccurate. So I wanted to show you that we can do this. This is why we learned international finance, to be able to define such models. But this setup, so the international Fisher rule, is not good enough for this environment. And also, the problem is that it has absolutely no idea right now that the inflation started to increase. And this inflation completely biased the real life data. So because inflation was higher in the US, it was higher in the Eurozone, and also because it was neglected by the European Central Bank. So that's why there is this depreciation, why it thinks that, oh, there is no inflation and the premium is still positive. So we are losing a lot of information.